Welcome, Hornets, and thank you for joining me today. Today we're going to be taking a look at how we solve functions that are quadratic in nature that either work with natural logs or exponentials. Let's take a look at an example. Let's say, for example, I have, let's look at e to the 2x minus 2e to the x minus 3 equals 0. Now, you might look at this and say, hey, wait a minute, I don't know what to do. But I'm going to tell you right now that this is a quadratic form. Now, the reason it's quadratic form is if I take a look at the middle term, and I use the exponential in the middle term, and I call that u. I'm now going to look for u elsewhere in the problem. And you'll notice that this is really e to the x, the quantity squared, minus 2, e to the x, minus 3 equaling 0. And I'm now going to replace e to the x with a u. This is called a dummy variable and is used to take a complex piece and kind of avoid using it for the time being until we know what it is. Then we'll go back and we'll solve it. So you'll notice I now have, by replacing e to the x with u, I have a u squared minus 2u minus 1. And this factors. And you notice I've got a 3 and a 1, and I want a negative and a positive. That means that if I'm solving, my u has to equal negative 1, and u has to equal a positive 3. The problem is, e to the x is u. And we know that e to the x is always greater than 0, which means that e to the x equaling a negative 1 is not possible. It is outside of the domain and cannot be solved. But e to the x equaling 3 can be solved by using a common log and exponentiation. I'm going to use the natural log, ln. ln e to the x equaling ln of 3. The power moves down, natural log of e equals ln of 3, and my solution is x equals the natural log of 3. This is my answer. The solution is the natural log of 3. And that's how we find it. Let's try another one. This time, let's take, let's go 2 to the 4x power plus 2 to the x power minus 3 equals 0. This is also a quadratic form. Look at the middle term and let u equal the exponential found in the middle. Now look at the other pieces and see if you can figure out what happened. This, after all, is 2 squared to the x, which means that it is actually 2 to the 2x, the quantity squared. Notice how right in here, I have changed the position of the x and the 2 so that I can see the power. I'm now ready to replace my u. 2u squared plus u minus 3 equals 0. And once again, this factors. 2u, u, and we want to make sure that we end up with a 1 difference. And I want to have a positive 3u and a negative 2u. And now I can see that my u is equal to negative 3 over 2. And u is equal to a positive 1. But my u is 2 to the x power. And once again, exponentials are always greater than 0, which means that this one is not possible. But this one, let's see, that was 2 to the x equals 1. Well, I could use exponentiation, or I could use my laws of powers and recognize that 2 to the 0 power is equal to 1, and therefore x must equal 0. This is where I can use my exponents and solve getting the same exponential base on both sides, where I can then drop the base. The solution is then 0. I'll just put it and write that down as a 0. All right, let's take a look at another one. What if I have the natural log of x, the quantity squared, minus 2 times the natural log of x, minus 8 equals 0. This is also a quadratic form. Take the middle term, and this time we're going to let u equal the natural log of x. That means that I have a u squared minus a 2u minus 8 equals 0. It then factors, and it will factor into u plus 2 and a u minus 4 equaling 0, which means that u is equal to negative 2 and u is equal to a positive 4. But according to our information, u is the natural log of x. And you'll notice we're now saying that there is no power of x that will make my power of e into a negative 2, because this will always end up giving me positive results. If you wish, you can look at it and say, let's think about it for a minute. I can get a negative result from this if I think, and I'm going to exponentiate just to make sure. And yes, x equals 1 over e squared. So that does have a solution. So I had to be careful. I was thinking, wait a minute, it doesn't inside. But that's outside, and that's an exponent. And exponents can be negative. Then we have the natural log of x is equaling 4. I'm going to exponentiate again so that x is equal to e to the 4th. The solutions are 1 over e squared and e to the 4th. And that's my goal. So take note that we can have quadratic forms. And once we figure out what the u is, our dummy variable, we then factor and find out what u equals. We then back substitute with what we already called u to equal. And then we identify whether it's a possibility or not. Being very careful. Notice right here, I almost made an error thinking that the natural log of x can't be a negative result, but it just means that the x can't be negative. That's the domain. So we're okay. All righty. This is using exponentiation and quadratic form in order to find a solution. I hope this has helped, and I hope this was useful to you. And these are the things that we will continue to work on over the next several days. If you have any questions, please remember to come on in and ask, and I will do everything in my power to help you. Otherwise, it's my hope that this is helpful. If it is, please remember to click like, and feel free to subscribe so that you can get more of these videos as I make them. Thank you very much, Hornets, and I hope you have a wonderful evening. Cheers. Bye-bye now.